Good morning, everyone. Today we're going to be solving the two-sum Leet code problem using the brute force method. And so let's take a look at the description and then see the method we're going to use to solve this problem. So it says given an array of integer nums, so it's like a vector of numbers, and an integer target. Okay, so we have one integer that we're looking for. Return the indices of two numbers such that they add up to the target. Okay, so essentially we're going to get a list of numbers. And from those numbers, we should have two elements which should add up to a specific target. For example, in this case, we want the target to be 9. So we could see that the elements 2 and 7 should add up to 9. So that makes sense. Now let's look at any kind of conditions they set on us for this problem. So we could assume that each input would have exactly one solution, which is good. So we don't have to consider about the edge case where if there's no solutions, we can return some kind of specific value, maybe like an empty vector or like the value -1 or so forth. And then also we cannot use the same element twice. So for example, if the target was 4, so I know it's 9 right now, but let's say, for example, if it was 4, I couldn't just do 2 plus 2. In that case, there would be no solution, just because no two numbers here add up, no two distinct numbers here add up to 4. But since they've already specified there's always going to be exactly one solution, that helps us. And then also we can't use the same element twice, which makes sense. So let's look at the examples. So here they give us these list of numbers. We could see that the elements 2 and 7 add up to 9. What they want us to return is the indices for those elements. So for example, the element 2 is going to be at index 0, and the element 7 is going to be at index 1. So that's this kind of example. If we look at this situation, we have 3, 2, and 4, and our target is 6. So we can see that 2 and 4 are the values which add up to our target. So this is going to be at index 1, and then this is going to be at index 2. And so that's pretty much what it's looking for and asking for. It's always really important to understand the problem before you tackle it. But now that we understand what it's asking of us, we're going to use the brute force method. So the brute force method is, what you're going to do is you're going to have two of the same list. So this is the example list that we have. And what we're going to do is that for each element, we're going to add it up to every other element within our list. So for 2, we're going to add it up to 2, although this would be disqualifying because we don't want them to be the same index. So 2 can't be added with 2. So we'll have like an if statement that'll discard those cases. But 2 would be added to 7, 2 would be added to 11, 2 would be added to 15. Then we have 7, which is going to be added to 2, 7, which would be added to 7. However, once again, if it's the same index, then we're going to disregard that. 7 added to 11, and so forth and so forth. So you can see for each member of the list, or for each element of the list, we're going to iterate through every other element within that same list. So that's going to be essentially 2 nested for loops, which is going to be O of n squared complexity. It's a brute force method. So now that we have that kind of said and done, and also if you don't feel comfortable with the logic, I definitely recommend kind of rewatching that, making sure you feel really comfortable with what I'm saying before we kind of continue with the implementation, just because implementing solutions doesn't really make sense unless you understand kind of what's going on, and so you can kind of put it on paper. Once you can put it on paper, then I recommend kind of going with the coding approach. But if not, then it's kind of like building a house without proper schematics. It doesn't really make sense. All right, so now let's start this. So we know that we want to be able to return our result as a vector. And actually, sorry, let's look at our inputs. So what do we have as our inputs? So we have our vector called nums, and we have the target that we're looking to sum up to. All right. And what are we looking to return? We're looking to return a vector of integers. So we're looking to return a vector which has those 2 indices that correspond to the elements that add up to the target. So the first thing I want to do is I want to create essentially what would be our return value. So let's do that. So here we'll have our vector of integers, and I'll just label this as found indices. And looking back at it, what I prefer is let's write our solution in here. I'm just a bigger fan of writing it within this online compiler. So let's do that. Here I have my vector of integers. Actually, if you are going to use this solution as well, just make sure to include vector, just because by default it only includes iOS stream. So just make sure to have vector included. Actually, let's go to the default just to see what you would see. You would see these comments at the top. I just always get rid of them. I go ahead and add some more real estate. Since we're going to be working with vectors, include your vector library. And then the next thing is going to be copying this over. So here, I'll have this class here. So here's where we're going to return our value, or this is where our vector for the return values, vector for the return values. Now, the next thing we want to do is we want to be able to populate them. In order to do that, we have to find the answer. So we've already mentioned that we have to go through this list called nums twice, right? We have to iterate through them twice. You could use, there is a for each loop available, but since we need the indices, we need to know what they are. You know, in that case, we're going to have to do our standard for loop. So for int I equals 0, I is less than nums.size, I plus plus. So this is just going to iterate through the list. Through the list. There we go. What we're also going to do is we're going to do another nested for loop to make sure that we're going through, for each outer element, we're going through also each other element. So this is where we're going to set up an index j. You know, feel free to name it anything else. I just name it kind of a short name for convenience, but not sure if index would be like perhaps a better name, but that's okay. Let's continue nums.size and j plus plus. There we go. So now that we have this set up, this is also going to iterate through the list. Now that we have this set up, we want to go ahead and be mindful of our exclusion criteria. And that is that you cannot add two values that have the same index. So you can't use the same element twice. So if they have the same index, then that's disqualifying. And we know that I is the index for the outer loop, and then j is the index for the inner loop. So we want to make sure that no two elements are used. And we can skip that either by properly setting up our for loops, or we can just like put an if statement here, and we could say that if I is equal to j, so if the indices match, meaning it's the same element, then just disregard them. And how do we disregard them? We just throw a continue in there, and it just skips this iteration. Right? It'll go to the next iteration, but it'll skip that current iteration that we're on. Now, the next thing that we want to find out is what is our first value, what is our second value? So our first value will correspond to the index I, our second value will correspond to the index j. So for readability, what I like to do is I like to set them up as their own variables. So in this case, I'm going to say that our first value is equal to nums at the index I. And I know that our second value will be equal to nums at the index j. Okay. So now that we have that set up, it'll make the rest of the logic a little bit easier. We kind of are searching for the instance where the first value plus the second value adds up to our target, right? So that's what we're looking for. And we've already excluded the fact that they can't be the same element. So we're in a pretty good position. So we say if the first value plus the second value is equal to the targets, then we know that we've found our match. So all we need to do is we need to add those two indices we need to push them back into our list. So here is going to be our first value, or first indices of the target element, or the, I don't know, sum element, I guess. So you can imagine that this is the 2 from earlier. So the 2 plus 7 equals 9. And then this right here, well, technically it would be the index for it. So it would be 0 because it was the first element. But just know that that's the first indices. And then we're also going to add the second indices to our list. Push back j. And this is the second index of the sum element. So this is equivalent to just adding the 0 and the 1, or the 1 and the 2, or the 0 and the 1 to our list. So now that we have those indices, we're pretty much done with our work, because we've been told that there's always going to be exactly one solution. So the way that we could get this to work is we can break out of this loop. That breaks out of the inner loop. But how do we break out of the outer loop? Just because the break statement only corresponds to the loop which contains it. So you could kind of think of it as a stack unwinding. That break is only going to affect the first for loop that it touches. It's not going to affect the outer for loop. So we can have another break statement, but we have to be careful. We have to say only when we found our answer. When we found our answer, do we break out of the outer loop. So how do we know we found our answer? Well, at that point, our vector should be filled with some values. So found indices, the size of it should be greater than 0 because initially it doesn't have anything in it. So if it's greater than 0, we know we've already kind of populated it with our answer. And so we know we're good to go. So that's pretty much the logic there. The last thing we want to do is we want to return our found indices, right, which is our answer. So you can imagine that this is the 0, 1 from the example problem, or let's say like if we had a really long list, it might be like 10, 25. If we had, these were the indices that added up to our target. Indices of the elements that added up to our target. But now the last thing we need to do is we have to just check that this works. So what we're going to do is we're going to copy this over. Actually, let's just make sure I didn't make any syntax errors. Okay, looks good. Copy that over to Leet code. And let's run that solution. Let's see. So it's looking good. Nice. So it worked in all cases. I hope that made sense. Please let me know in the comments if there's any questions about this approach. Once again, because we're using the nested for loops, that's why it's going to be O of n squared. It's not necessarily just because it's nested for loops. That's kind of like a convention, but it's because we're going through the list. Essentially, for each value of the list, we're going through the list number of times. So for example, just going to give a quick breakdown really quickly. So let's say, for example, my list is 1, 2, 3. And here I have 1, 2, 3. So you can see how there's going to be 9 values because, or nine iterations total, because for the first one, I'm going to pair it with 1, then 2, then 3. And for the second value, which is 2, I'm going to pair it with the 1, 2, and 3. And then for the third value, pair it with 1, 2, and 3. Now, of course, we are kind of continuing through iterations. We're kind of breaking out, so like little optimizations here and there, but overall, it's going to be O of log O of n squared time complexity. But I hope that made sense. It's been quite a while since I've made any videos, so please excuse any kind of little quirks that I had in the video. Thank you so much for watching, and I hope you continue watching with these next Leet code solutions.